Number 3, we have a compound that contains 54% barium, 38.1% oxygen, and 7.9% hydrogen, and determine the empirical formula. So let's say we have 100 gram of compound. To make our calculation easier, so that means we are gonna have 54 gram barium, 38.1 gram oxygen, and 7.9 gram hydrogen. Now what we want to do is change our gram to mole. So we have 54 gram barium times 1 mole divided by, this is our atomic mass of barium. So when we go and look the atomic mass on the periodic table, we'll get this number. So, and when we do the maths, we'll get 0.39 mole, and we got 7.9 gram of hydrogen times 1 mole hydrogen, and 1.002 gram hydrogen would be the atomic mass of hydrogen, and we'll get 7.9 mole of hydrogen, and we got 38.1 gram of oxygen times 1 mole oxygen divided by 16.00 gram of oxygen. 16.0 gram is atomic mass of oxygen, and we'll get 2.4 mole. And when we change to empirical formula, we need a whole number, but we don't have a whole number right here, so we need to divide every quantity we have by the smallest mole we have. The smallest mole we have would be 0.39 mole, so we will divide every quantity by 0.39. So when we divide this by 0.39, we'll get 1. That would be our for barium, so that's a whole number. We got 7.9 divided by 0.39, we'll get around 20.3 something, and that's closer to 20 than 21, so we'll round it to 20. And we got 2.4 mole. We'll divide it by 0.39, we'll get 6.15. When we round it, we'll get 6 because it's less than 5. And this would be our equation, barium 06H20. That would be our empirical formula of 54% of barium, 38.1% of oxygen, and 7.9% of hydrogen in empirical formula.